Hi, this is Module 3, Engage New York, Topic A, Lesson 3. We are going to talk about our exponential function, and we've started to talk about this. And first thing you're going to do is you can pause the video and you can sketch this graph in your notes. This is 2 to the x, y is equal to 2 to the x. And really you have to just plot some points right around here, these points. And then draw in a curve. While we're here, we're going to make a table of values. We have x, and then we are going to talk about 2x, and it's going to give us a y value. So if my x value is 0, then I'm going to plug in 0 for x, and I'm going to go that y is 1. And then if I plug in 1 and plug in 1 for x, then my y is going to be 2. And then 2 squared, that'll be 4, and 3, 2 cubed, that's going to be 8. This is awesome. So we know that every time we put in another interval of x, we're going to get a much larger value of y. So what's happening between the interval of 0 and 1? What are these values right here? So let's zoom into these values right over here on this next part. And if you notice, we still have the same graph, y is equal to 2 to the x, except we've zoomed into 0. Here's our x value is 0, and here's our x value is 1. And let's take a look at our graph. We're going to find two consecutive, let me get my highlighter out, two consecutive. Consecutive integers means that they go in a row, like 1 and the consecutive integer is 2. Or 15, the consecutive integer is 16. So we're going to find two consecutive integers that are over and under estimates of 2 to the 1/2 power. All these, this is good. This is the value estimate for 2 to the 0 power. This is the value for 2 to the power of 1. So if we want something around 2 to the 1/2 power, well, 0.5 is also equal to 1/2. So we want our value for y to read right around there. So an underestimate would be here, and this x value is 0. And then an overestimate, I'm looking at the y value. The y value for the overestimate is 1. So our 2.5, 2 and to the 1/2 power is going to fall between between 2 to the 0 power and 2 to the 1st power. Okay. Does it appear that 2 to the 1/2 power is halfway between the integers you specified in exercise 1? Well, 2 to the 0 power, that's equal to 1. And then 2 to the 1st power is equal to 2. In the middle is 1.5. But 1.5, we know 1.5, it's around 1.5, but it's not totally 1.5. 2 to the 1/2. So 2 to the 1/2 power is less than 1.5. That's what we're reading right here. Here's 1.5, the value 1.5. And then our green dot right here is the actual value. So it's still an overestimate. So let's use the graph 2 to the x power to estimate the value of 2 to the 1/2. Let's zoom in. We're going to read the y value. If our x value is 1/2, our y value is maybe around 1.4. Okay, use the graph of f of x 2 to the x power to estimate the value of 2 1/3. Okay, let's go back to our graph. 2 1/3, I shall make you purple. All right. 1/3 is about 0.333333. So this is 0.1, 0.2, 0.3, so a little bit after this. And I'm going to go up to my function. And I'm going to read, what is that y value right there, my purple dot? 1.1, 1.2, 1.3, 1. So it's between 1.2 and 1.3. So I'm going to call it around 1.25. All right, so I don't really know what 2 1/3 is. or 2 1/2 is? Oh, this is the theme, by the way. Let me go back to the title. The title of these notes, it's lesson 3, and we're going to deal with the magical numbers 2 to the 1/2 power and 2 to the 1/3 power. So in this video and on Monday in your next class, every time we talk about 2 to the 1/2 power or 2 to the 1/3 power, that's where you have to pay extra special attention. Okay, let's go back. So we found some numerical values. If I said, what's 2 to the 1/2 power? You'd be able to say, it's about 1/4. And if I said, what's 2 to the 1/3 power? You would say, it's about 1.25. And I would say, great. Then I would ask you, what does 2 1/2 mean? What is this 2 1/2? 2 to the 1/2 power. Let's see what this could be. We want to rewrite this with a radical, believe it or not. Now I want you to remember over on the side that 2 to the m times 2 to the n is equal to 2 to the m plus n. So let's go back to here. Let's multiply 2 1/2 times 2 1/2. Let's see what we get. Well, we know that's 2, and that's going to be 1/2 plus 1/2. I'm going to rewrite this. And that's going to equal to 2 to the 1st power. What do we know from our previous knowledge? When we multiply it by itself, we're multiplying 2 to the 1/2 power by itself, and we're getting 2 back. Does that sound familiar at all? What if we multiply root 2 times root 2? We're also going to get our 2 back. So are these equal? You bet. 2 to the 1/2 is equal to root 2. Now, does this work for other numbers? And what does this 2 have to do with this radical? What you have to remember is that in a radical, you have a tiny invisible 2 on the outside. This 2 goes with that 2. The big base goes with what is inside the radical. Does it work for other numbers? The other number we were dealing with today was 2 to the 1/3 power. Let's try doing the same thing. What is 2 to the 1/3 times 2 to the 1/3? That's going to be 2 to the 1/3 plus 1/3 plus 1/3. Notice that this little 3, that's how many times we're multiplying it by. That's how many times we're adding it by. And that's going to equal to 2 to the 1st power. And what else do we know that when we multiply it by itself 3 times, we're going to get that number back? Well, if we cube 2, if we cube the cube root of 2, we are indeed going to get the inside of our radical back. Cube root of 2 times the cube root of 2 times the cube root of 2. If you cube something, let's see, the cube root of 2 cubed, you're going to end up getting your insides of the radical back. So does that mean that 2 1/3 is equal to the cube root of 2? It totally means that. And does it work for all? If this index here instead of a 3 was a 4 or a 5, so does the 4th root of 2 equal 2 to the 1/4? Yes, it does. And it works for all numbers. So that means 2 to the n will equal the nth root, I'm saying it again, nth. So this is how I'm saying it. Nth root of 2. Oops. Oh my gosh, very important. This is 1 over n. That's the nth root. Just like we'll have 1/10 or 1/16 or 1/1,000,000th. It's the nth root of 2. So this works for other numbers besides 2. You have 4 examples right here. What is the 4th root of 16? The 4th root. What is the 4th root of 16? Or that's equal to the 4th root of 16, and we know that's equal to 2, because 2 times 2 times 2 times 2 is 16. So what is the cube root of 125? So 125, cube means 3. So the cube root, which is also written like this, the cube root, and we know that's equal to 5 times 5 times 5, or just 5. Oh, we only have 3 examples. What is the 5th root? So we have 100,000 to the 1/5 power, and that's equal to 5 square root of 100,000, and that'll be 10. On Monday, absolutely know this part in your summary. I think you could probably summarize this video in one sentence. If you understand this concept here, where's my highlighter? This concept here, then you're good for Monday. Bye, everyone. That's it. How do I stop this?